Welcome back. I remember mentioning last time about intervals when I was talking about it, how the unison is the same frequency, and I wanted to mention a little bit more about it. Thinking about vibrations and waves and patterns. One of the things that made Pythagoras, the mathematician who left us that idea of the diatonic scale, he was investigating what was beautiful in nature, what in his mind was divine. What was it? We see things in nature that strike us as very beautiful and very interesting and very unusual, like a rainbow. Or you could probably think of some other things that are interesting. And the quest to understand how these things become what they are has led many people to discoveries. Pythagoras heard something in the octave, and that octave that we talked about was so interesting to him. The other interesting interval was the fifth. And there's a reason for that, scientifically. And he looked at strings to see how they vibrate. And he saw a beauty, a mathematical beauty, in these different frequencies, these vibrations. And there's a numerical way of looking at it. If the vibration of the octave is 2 to 1, in other words, if the one is vibrating at, let's say, 400 cycles a second, well, the octave is then vibrating at 800 times a second. It's 2 to 1. Everything in the universe seems to have a way of expressing itself as waves, energy, electromagnetic energy, sound waves. Although at this point I'd like to mention to you that most of you have watched a lot of movies showing spaceships in space and battles. I think of Star Wars and things like that. But did you know, and I think most of you do, when you hear those battles in space and watch those things zipping around going, there isn't any sound in space. That's because in order to have a sound received, a wave has to exist. And the wave has to have a medium to go through. Sound waves can get created, and they wiggle the air. When I wiggle the air, if there was a person here, you'd hear that wiggle. What happens in this recording I'm making is that the recorder inside this camera and receiver here, that's turning the analog wave into a series of digital numbers, which are then stored. It's so fascinating because on playback, the opposite occurs. The digital numbers get translated back into frequencies and then get transmitted, in this case, wirelessly, out of what we used to call Hertzian waves, radio waves, the invisible waves. There are waves everywhere at all times. And it was the discovery of these waves that led to the breakthroughs in science, especially in the last 150 years, that lead to things like you watching this on a computer somewhere or on your phone and communicating instantly using electrons. Electrons. Think about it. Don't think about that long. I just thought about it. Boy, it's fascinating to me. And I wanted to let you know that there are patterns in nature, patterns in music. And the most, in music, the interesting pattern that we want to discuss today is the overtone series. Okay? Let's take a deeper dive now. Here's the overtone series, starting on C, 2 octaves below middle C. all of those pitches, those vibrations, they're included in this first vibration. Here's a guitar, and as you can see, there are strings on it, of course. And one of the things that happens in a wave is that there are inside the wave what we call partials or harmonics. Let me demonstrate. If I dampen the string very slightly, I'll be suppressing the fundamental tone, yet the partial harmonics that occur in the overtone series, the partials, the harmonics, will ring out. Listen. Hear that? Instead of, you're hearing the harmonics, the partials. And they happen all over. They're everywhere. Dampen the string. If I was a guitar player, I could do this really well. Let me see, I'll find some for you. I think there's one here. There's one. There's one. Hear him? A recorder, an ancient kind of flute. And it makes a sound because it has a column of air. And if you close up all the columns, all the holes in the column, you'll get a fundamental pitch. Maybe I'll get it now, or maybe not. And as you open your fingers on these openings, you shorten the column of air, of course, and you'll get a scale. And then you can play like John Lennon and the Beatles. Never mind. But I want to show you, if I overblow this, let me pick a note like this. If I blow too hard, I'm going to create one of those partials. It's annoying, but you'll lose the fundamental tone, and you'll get a sharper partial. Oh, there it is. All I did was I increased the amount of air. Hear it? Happens all the time. So when you're playing the recorder, you don't want to overblow the air through the column. Want a nice even tone. Okay? That's a little demonstration of what we call partials, harmonics, and they have to do with the overtone series too.